here are 3 insect phylogenies picked at random, and what these don't really tell us in the way that these are presented is how are these covering insect diversity. How do they cover diversity in relation to what was published beforehand, and also how do they cover diversity as a whole, i.e. all the species here, were all these present in the previous published phylogeny, or all these novel, or is this larger than the previous one? And also as a whole, what does this cover of known diversity? Are we missing major sections, or are we focusing too much on certain components? So these kind of questions are not really addressed. So if we were to address them, we would need, if we were to quantify these kind of questions, we would need a framework of diversity, such as a taxonomic database, a list of species, and we would need a collection of phylogenies, and then we could determine where are the gaps in, where were the biggest gaps in phylogenetic coverage, and where do we need to focus our efforts if we're going to optimize our voyage to completing the tree of life. So these 2 things, so we need a database of taxonomy database and a phylogeny database. So I'll start with a relatively easy one first, the taxonomy database. So there are several. I will just go straight to the one I opted for, which is the Catalogue of Life. So some of the main tools I've used in this study you can get from this address here. So go to Catalogue of Life, and there's different formats of the database. Just click on text tree. This is a pretty simple format, and you've got a file, something like this, and the main database. So I did this last year, 338 already. The file was downloaded, the latest one, and it's a bit bigger, and I've already noticed some format differences in this. So we just look at the one from last year. Here I've just searched for a species of honeybee, and you can see the format here. We have species and the last item being species in square brackets, and there's like a step of what looks like species, and then we have what looks like subspecies names. Yeah, subspecies, which is denoted here. The latest version of the Catalogue of Life taxonomy looks like this. And you can see they've changed some formats. Previously, the lower rank, the two subspecies had a star character, and now they put a equal sign, and there's also for some reason there's a ID after the assignment. So some format changes. Now you can get older versions of the Catalogue of Life, as you can see. So just to state that this script is written for that specific version, and with these new changes, there will be some slight changes required to the script to work on the updated versions. Anyway, just to parse this file, we'll just select job 1 here, save, and parse the Catalogue of Life taxonomy. So pretty simple, scanning that large file, looking for class in sector, and then printing those lines. Again, this will need, probably I think is this one will need changing for the updated format, but removing synonyms and subspecies. And that's all it's doing at that stage. So then we get that's written to this file here. So you can see it's the same, roughly the same format, but these subspecies and synonyms been removed and limited to the insects, and to the, here we can just pull out the species that are on their own, count them, and thus we have about 970,000 species in the catalogue of life. So next I convert this to a simpler taxon table format. So here using the same script, and you just change that to 2, and we're going to therefore run this subroutine. So particularly we're interested in species, these are most important, so these are being parsed here, and we have unfortunately rather a few different formats that we need to deal with. For example, the name of the original taxonomist just placed after along with the year, or perhaps in brackets, or perhaps this is not included at all. So several different formats we need to try and read. Also, in some cases people will put say subgenus name in the middle of the binomial. So we now should have more of a simple tabular format for the insect taxonomy, and you can see, yeah, the format is pretty similar to that used by NCBI taxonomy, where you have the first two being the node ID and the parent node ID and the name, and we have genus, family, species, and so on. So we can scan this for what we want. For example, so here's the node ID for the beetles, and the parent node is probably the root in sector here, and order corresponding to the third column, and then we can see all of the child nodes coming off the beetles, which are all these here. We'll include several different ranks depending on what is currently being assigned. So finally, the main thing I do for the taxonomic database, I actually convert it to a NUIC string. This is mainly for plotting really, but it's rather a simple format I'm used to working with. So let's find so this is taxon table to NUIC. That should also be in here. You can also obtain this from GitHub. Let's run this for the grasshoppers. So the output from this, we should have a NUIC format string for the grasshoppers, complete for whatever is on catalogue of life. We should be able to just plot this with a tree viewer. For tree viewer now, I always recommend Archaeopteryx. It's one of the few which really scalable software and should work for very large things. And here we have the process catalogue of life, taxonomy of the grasshoppers. Let's just click this node, and we have 29,000 species of grasshopper, and you can see the quite neat formatting for the species ID, the particular binomial being comprising genus and species. So now we have this. What we are trying to do is we can just simply say what proportion of these species are present in a collection of phylogenies and what proportion are absent, and we can look for, say, families which have a large proportion of things absent, and these are relatively where we should be focusing our efforts. These are where the large part of the Darwinian shortfall exists.